it saved you a little bit of time in your day or something like that. I don't know. Anyway, it's less than ideal, but it's certainly better than nothing. So what I want to do is I want to first say that we are going to be starting section 1.5. And after section 1.5, which we'll spend a little bit of time in, it's not a huge section, but it is something that will take a couple of days to go through. We then have one more section, 1.6, and then we're going to have our first test. So what I want to say is that our first test is right around the corner. At this point, if you look on our syllabus, which is on our Moodle page, and it's also on the MyOpenMath page, you will see that the test at this point is scheduled to be a week from today. I don't know that it's actually going to happen a week from today. It might be a week from Friday, but I at least wanted to let everybody know that we are right around the corner to be taking the test. Okay, so I will say test 2. It's tentatively scheduled for next Wednesday. It might be moved to Friday. We'll just see, but you can expect that to happen in a week. Any questions there? All right. There we go. Now you get to see something more interesting than my face. You get to see math in a moment. All right. So, and don't worry, before you take the test, I will talk about the test so that you know exactly what to be prepared for. But all of you have been attending so regularly and are doing wonderfully. So, I don't want it to be something that you really stress out too much about. And recall that you also get a sheet of paper with notes for your test. So, all right. So this next section, 1.5, is called transformations of functions. And as I mentioned at the start of the class, this semester, chapter 1, we're really laying the basic groundwork for all functions. And then we're going to take these ideas and apply it to linear functions, to exponential and logarithmic functions, and then to polynomial functions. So the ideas that we're going to be using here in this section of transformations of functions, you're going to keep hearing me refer back to as the semester progresses. Okay. So what I want to do is I want to start out by drawing a picture. Okay. So I'm going to take one of our toolkit functions. I'm going to take the square root function. Okay. So if we're given this function, y is the square root of x, or we can say f of x is the square root of x. I want us to graph this as well as, how about the square root of x plus 3, and then the square root of x minus 3. And I'm going to make a comment about these momentarily, but first just bear with me. Okay, I'm going to grab a couple other colors out of my pack here so that we can distinguish between each of them. So you may or may not remember your toolkit function, the square root of x. But the nice thing about that is we can make a little XYT table. Would you all agree we've got some domain issues going on here? Right? You can't take the square root of a negative number. So we need to have x be greater than or equal to 0. If I plug in x equals 0, what's the square root of 0?
0.
Thank you. If I plug in x equals 1, what's the square root of 1? 1.
One.
Now I'm going to jump to my next nice number to do this with. If I plug in x equals 4, what's the square root of 4?
2.
2. And we could keep going, but one of the things that you'll see is we got 1, 1, and 1, 2, 3, 4, and we're up at 2. Okay, so this is our square root function. Now, what if I wanted to graph this one? In other words, if y is the square root of x plus 3. Well, let's plug in some values. If I plug in x equals 0, what comes out for y now? Well, what's the square root of 0?
0.
And then we add 3. Good. So 3 comes out. If I plug in x equals 1, what comes out? Good job. Thanks, Ross. And finally, I'm going to take 4 because that's a pretty nice number. If I plug in x equals 4, can somebody tell me what comes out? Don't we get 5? And we can plot this. Now, if I plug in x equals 0, I'm up at 3. If I plug in x equals 1, I'm now up at 4. And now, if I plug in x equals 4, I'm up at 5. Do you see how my curve looks very much the same? But what happened to each of our function values? Didn't each of our function values go up by 3? So, can anyone give me a guess as to what's going to happen if we want to graph this one? Well, let's plug in values. We'll plug in 0, 1, and 4 again, because those are the 3 nicest values to plug in. If I plug in x equals 0, can someone either verbally tell me or chat out what comes out?
Is that undefined?
It's not undefined because notice we're only plugging 0 in here.
Okay, all right, thank you.
No, good eye. That's awesome, Ross. Okay.
Well, then
this-
I'm assuming it's -3 then.
and you are assuming correct,
All right.
right? Because the square root of 0 is 0 and 0 minus 3 is -3. What if I plug in x equals 1?
-2.
Good. -2 comes out. And what if I plug in 4?
-1.
-1 comes out. Well, we can graph this as well. Notice that we're at 0, -3. We're at 1, -2, and we're at 4, -1. And there's my graph. Do you agree if I define my function f of x here to be the square root of x, then isn't this f of x plus 3? And isn't this one f of x minus 3? My general function f of x was the square root of x. So we have f of x plus 3 and f of x minus 3. And what happened to our graph when we added 3 to it? Didn't we move up 3? And what happened to our graph of our function when we subtracted 3? Didn't we move down 3? Isn't that cool? So, to summarize this sort of function transformation, what I'm going to say is if you have a function f of x and you take some constant k that's positive, if you add k to that function, you take your graph and you shift it up k units. And if you subtract that value from the function, you shift it down k units. Okay, these are called my vertical shifts. And that's f of x plus or minus k. Now, the other thing that I want to point out to you very quickly is notice we kept plugging in the same values of x. Those we didn't mess with, but notice our y values either increase by 3 or they decrease by 3. Okay. So if you're given a table, suppose you're given this instead. I'm just making up random values for a function. Okay, so suppose my function brings 2 to 1, 4 to 3, 6 to 7, and 8 to 11. What if I wanted us to create a table for f of x plus 2? Notice my function, my x values are not changing. But now what am I doing to each function value here? Aren't I adding 2? So what would come out if I plug 2 into this new function? I'll write f of x plus 2. There we go. Well, f of x was 1 plus 2 makes 3. Good. What would I get out here?
5.
5, 9, and 13. So notice with each of these with a table, the input stays the same. We didn't mess with our x values. Only the output changed. Questions this far?
Nope.
Cool. All right, so those are some transformations that we do. Again, they're called vertical shifts because we're adding and subtracting from our y values, so it's shifted vertically. Okay. So now I'm just going to give you a short word problem, and we're going to analyze this. So suppose I tell you that I have this function, I'm calling it h of t, and I'm even going to write what that function is. Okay, and suppose I tell you that that function gives the height h of a ball, and I'll say that the height h is in meters, thrown upwards from the ground after t seconds. So when you plug in t equals 0, in other words, initially, the height is 0 meters, which makes sense. Okay, now let's take the idea of what we just did and suppose instead the ball is thrown from the top of a 10-meter building. And what I want you to do is give the equation for this scenario. And I'll call it n of t because it's our new function. Let me know when you have this written down. I don't want to talk too fast for you all. Well, what are we doing here? I mean, we're doing our basic function, but now instead of starting at ground level, aren't we starting 10 meters higher? So won't each of the heights be 10 meters more than what it would have been if we had thrown it from the ground? So can somebody either type or tell me what would this look like? Well, h of t is negative 4.9 t squared plus 30 t. And now what do I do?
Add 10.
Add 10. Beautiful. All right. So these are our vertical shifts. We're going to be playing with these a lot throughout the course, and remembering these is going to be so helpful for when we're graphing like exponential functions and logarithmic functions. We're going to come back to this idea. Okay. So what I want to do now is move to another sort of transformation. And again, let's suppose f of x is the square root of x. Now what I want to do is I want to graph y equals the square root of x plus 3 and y equals, the square root of x minus 3. And before we even do that, I claim now, if f of x is the square root of x, isn't this guy just finding f of x plus 3? And isn't this one finding f of x minus 3? Right? Everywhere where I see an x in my function f, I'm plugging in x plus 3. And everywhere where I see an x in my function f, I'm plugging in x minus 3. So I want to contrast that before we even graph this to the difference between what we're doing now versus what we just did. That is the square root of x plus 3 and the square root of x minus 3. So when you're adding or subtracting without, again, we saw that we have a vertical shift. Here, I claim, again, I'm finding f of x plus 3 and f of x minus 3. In other words, I'm adding or subtracting a value within my function, not at the end of my function. In other words, my input is being affected, whereas here we took our output and tweaked that slightly. Does anyone have an idea of what happens with these? Okay, well, I do. Here's my function, y equals the square root of x. There's 1, 1. And there's 4, 2. Okay. So let's do this first one. If I want to graph y equals the square root of x plus 3. Note, I've got some domain things going on, don't I? Right? What's my domain here? What do we need x plus 3 to be?
It can't be -3, correct?
Good, we need close. We need x plus 3 to be greater than or equal to 0. You can't take the square root of a negative number. In other words, we can only plug in values that are greater than or equal to -3. So for example, if I plug -3 into my function, what is -3 plus 3?
0.
0, and the square root of 0 is 0. Okay. What if I plug in, I want to be really mindful of the values that I plug in so I don't make it a real pain. What if I plug in 1? What comes out here? Not a rhetorical question. What is the square root of 1 plus 3?
2.
2, good. It's the square root of 4 or 2. I could also plug -2 in here if I wanted to. That's in my domain. -2 plus 3 is 1. And what's the square root of 1? It's 1. So I'm going to graph this one in this blue color. Now I'm at -3, 0, -2, 1, and 1, 2. What happened to my graph here? Didn't I shift it horizontally to the left? 3 units? Well, given that, I want someone to give me a conjecture as to what's going to happen to this one. Good job. It's going to be to the right 3. Again, we've got domain issues. We need this thing under the radical to be greater than or equal to 0. In other words, we can only plug in values that are greater than or equal to 3. Well, can't start smaller than 3, so let's start at 3. If I plug in x equals 3, I have 3 minus 3 is 0, and the square root of 0 is 0. Okay, I can plug in 4. What am I going to get out when I plug 4 in? 1. Good job. And I'm not going to plug in 5 or 6 because you don't get as nice numbers, but I can certainly then plug in 7. 7 minus 3 is 4, and the square root of 4 is 2. So you were exactly right. It shifted 3 units to the right. Now I want to write this out very specifically with horizontal shifts because it's counterintuitive for people, right? When we added 3 to our function, it made sense that we went up 3, right? You add 3. When you subtract 3 from your function, it makes sense that we went down 3 because we were subtracting 3. But notice when you add inside, it goes to the left. And when you subtract inside, it goes to the right. And the reason why is because you've got to set it equal to 0, and then you get the opposite sign of whatever you had here, right? You set that equal to 0, your starting point is -3. And if you set this equal to 0, your starting point is +3. So what we have now are our horizontal shifts. Again, for some function f of x, and for some constant k greater than 0. If I compute f of x plus k, that means we go left k units. And f of x minus k means that we go right k units. And to kind of bridge the similarity between this and what we had just done with the vertical shifts is, in this case, our output stays the same. It's our input that we're changing. All right. So let me take like a quote unquote real world example. Suppose g of x is a function, and what it stands for is it's the number of gallons of gas needed to drive X miles. Okay, so my input is miles and my output is gallons. And I think you'd grant me that the number of gallons of gas needed certainly depends upon how many miles you're traveling. So what I want us to do next is interpret what is g of x plus 4. And then we're going to interpret what is g of x plus 4. Here I'm adding 4 on the outside. Here I'm adding 4 on the inside. Well, do you agree here we're adding 4 to the output? Right, I'm taking my output and adding 4. Well, what does this mean in the context of the question? Well, isn't it 4 gallons more than what is needed to drive X miles? Right, we're adding 4 onto our output, which is our gallons. So if this is the number of gallons needed to drive X miles, well, it's that many gallons plus another 4. In this second circumstance, we're adding 4 to the input. So the way I would interpret this one is it's the number of gallons needed to drive X plus 4 miles. Any questions this far? Okay. Are y'all doing okay this far?
Yep,
Cool.
I'm following.
Awesome, awesome. Is this familiar to you or is this new? Familiar, okay. All right, well, we are going to do a couple more things in this section. So the first thing that I am going to do, or the next thing that I'm going to do, is I'm going to talk about vertical stretches and compressions. We're not going to be doing horizontal stretches and compressions in this class, just so you know. You'll get to that one in trigonometry. Well, I'm going to take a different function. We've been playing with the square root function for about 30 minutes. And so for our next 8 to 10 minutes, why don't we play with a different one? Now I'm going to take another toolkit function, y equals x squared. In other words, I'm going to say, let's let f of x be x squared. I want to graph this, but then I also want to graph y equals 2x squared. And then I want to graph y equals 1/2 x squared. Would you agree that what we're doing is we're taking our function f of x and we're just multiplying it by some value k? Okay, I claim what we're looking at is k times f of x. And right now we're just considering values of k to be positive. Well, I'm going to make just one giant table so we don't have to draw a whole bunch of them. We saw one like this in the online homework recently. If I plug in x equals 0, what is 0 squared? It's 0. Okay, now let's plug it into this function. What is 2 times 0 squared? 0. And 1/2 times 0 squared is also 0. Now I'm squaring this, so I'm going to say, well, let's look at positive and negative 1 simultaneously, because when you square both positive and negative 1, you get the same thing. So if I plug in positive or negative 1, what comes out for x squared? Don't we get 1? Now what we're doing is we're taking 2 times that x squared value. So what do we get here? Okay, well, it's 2 times 1 squared, or 2. Okay, notice here's my x squared value. We're just taking it and multiplying it by 2, right? 2 times positive or negative 1 squared. So that's 2 times 1 or 2. What if I take half of 1 squared? What comes out here? Don't I get 1/2? Notice I'm just taking 2 times whatever my function value is. And in this case, 1/2 times my function value. What if I plug in positive or negative 2? Well, what do I get when I square plus or minus 2? Okay, not yet, not yet. I love that. Yes, for that. So if I plug that into x squared, do you agree that 4 is going to come out? 2 squared is 4, negative 2 squared is 4. Now notice what I'm doing is I'm taking 2 times whatever my function value is. What is 2 times 4? 8. right? I'm looking at 2 times 2 squared. 2 squared is 4, times 2 is 8. Now, what if I take 1/2 of 2 squared? Well, what comes out here? 2 squared is 4. And what's 1/2 times 4? 2. And the same thing happens whether it's a positive or negative. So if I'm to graph this, let's see what happened to our graph. I have 0, 0, positive or negative 1, 1, 2, negative 2, 4. Okay, here's my basic y equals x squared function. Well, let's now plug in 2 times x squared. Well, when we plugged in x equals 0, 0 still came out. But now when we plugged in positive or negative 1, 2 came out. And when we plugged in positive or negative 2, 8 came out. So isn't our graph kind of taller and thinner, or it's stretched up? But really, didn't we take each function value f of x and multiply it by 2? So what do you suppose is going to happen right here with 1/2 x squared? Well, we got 0, 0. If I plug in positive or negative 1, instead of being at 1 originally, now I'm at half that. And if I plug in positive or negative 2, instead of originally being at 4, I'm at half of that. So this time, we didn't shift our graph left or right or up or down, but what we did is we stretched it or we compressed it. So what I will say here is that when k is greater than 1, again, this k, the graph is stretched. It kind of thins it out. And if k is between 0 and 1, the graph is compressed or widens. Any questions this far? Okay, I've got one more thing to do, and then what I'll do is I'll kind of summarize this, and then we'll jump back into this on Friday, and we'll be able to wrap it up on Friday. Okay, so the last thing that we're going to be doing are reflections. Sounds like we're about to do some journaling, right? And I'm going to go back to my square root function. And what I'm specifically wanting to know is if f of x is the square root of x, what is negative f of x? And what is f of negative x? Okay, notice I'm first asking negative on the outside, and then I'm asking what if we replace x with the opposite of x on the inside? Well, would you grant me that if f of x is the square root of x, then negative f of x is negative square root of x? And if f of x is the square root of x, what does it mean to compute f of negative x? Everywhere where we see an x in our function f, what are we going to plug in? Negative x. Now I know that looks funky, just bear with me. Are there questions how I got these? Well, let's graph them, okay? We know that our general square root function looks like this. We've been graphing that one today. So let's now graph this one. If I plug in x equals 0, what's the square root of 0? 0. And what's negative 0? Isn't that still 0? What if I plug in x equals 1? Well, first thing we're going to do is take the square root of 1, which is 1. And then we have this negative sign hanging out in front. So what comes out here? Not negative 1. You're all pretty quiet. I want to be sure that you're with me. So it's cool if you're quiet, but you need to reach out if you have a question, whether it's chatting or unmuting. Okay, so tell me, somebody type it in the chat box. If I plug in x equals 4 here, what comes out with my function? Beautiful. Negative 2. So if I graph that, I'm at 0, 0, but now I'm at 1, negative 1, and 4, negative 2. Didn't it take my graph and reflect it about my x-axis? But really, if this is where f of x is, the opposite sign of f of x is going to be on the other side of that axis. So I'm going to say negative f of x takes your graph and it reflects it about the x-axis. All right, one more thing to do today, and then we'll call it good. Okay, let's graph this one. Can I plug in x equals 0? Yeah. Negative 0, 0, and what's the square root of 0? It's 0. Do you all see that I'm going to have domain issues right here? Okay, let me go up here. Don't I need whatever's under my radical to be greater than or equal to 0? Well, if I need whatever's under my radical to be greater than or equal to 0, good job. Okay, we don't want negative x, we want x. What happens when you multiply or divide by a negative number? It bebops the sign. Okay, so we can't plug in x equals 1 because then we're taking the square root of a negative number and we get an imaginary number. We can only plug in values of x less than or equal to 0. So let's do it. What happens if I plug in negative 1? Then aren't I taking the square root of negative 1? And what's a negative times a negative? It's positive. And what's the square root of 1? 1. What if I plug in negative 4? What do you think is going to come out there? You can type it in the chat. Beautiful, 2. Right? Because negative of negative 4 is a positive 4. So if I was to graph this, we're still at 0, 0, but now I'm at negative 1, 1, etc. And I claim this is what my graph is going to look like. In other words, f of negative x reflects the graph about the y-axis. Are y'all okay? Cool, cool. Well, I think that this is a good place to leave off for today. Again, make sure that you're keeping up with your homework and don't forget, we've now done through section 1.4 and this is 1.5. And don't forget at the beginning of class, I announced that our test 2 is going to happen next week. I would imagine it's probably going to happen next Friday, but we'll talk about that on Friday in class, where I will be there live. So thank you all. I appreciate your participation and I hope you have a super awesome day and I look forward to seeing you in person on Friday. Thank you.